Combination of logarithm and logarithm integral functions. So we have this integral from 1 to infinity of Li of x to the power minus 1 log of p to the power minus 1, yes, to the power minus 1 and x dx. Yes. Now we know that Li of x is just logarithm integral function, and there are both logarithm integral function and log, so by which I have named this integral. And this is defined as integral from 0 to x of 1 by ln of t dt. Yes. Now, there's something to notice. Over here, to solve this integral, I will basically going to make a new integral where I will use Feynman's technique. There's a reason behind doing that, and I will assume that I of a is Li of x to the power minus a, and then log of b to the power minus 1, and then x dx. Yeah. Now, let's see if the function f of a is Li of x to the power minus a. Let's try to find its derivative. Yeah. First of all, if we try to find its derivative, firstly, just differentiating this integral, we just get that, and this will be 1 by ln of x to the power minus a. Yes. And then derivative of x to the power minus a, which will be x to the power minus a times ln of x, and then derivative of minus a is minus 1. Yeah. So this is minus ln of x to the power minus a by minus a ln of x. Yeah. And these two cancel out, minus minus cancel out, and we finally have x to the power minus a by a. Okay. Now this is the derivative of the Li of x to the power minus a. Yes. Now using this result, we will be able to simplify this expression. Yeah, you see, this will simplify a lot. We get I dash of a will be integral from 1 to infinity of x to the power minus a by a, and then log to the power p minus 1 x dx. Okay, now how do we begin solving this one? Now we can take a outside, and we have I dash of a is equals to 1 by a integral from 1 to infinity x to the power minus a log to the power p minus 1 and x dx. What we can do is we can let y is equals to log x. Yes, and yeah, with that, this integral limits of integral will be nicer. Yes, 1 by a limits of integral will be from 0 to infinity. And now this will just be e to the power minus a y. Now y to the power p minus 1 and x equals to e to the power y. So dx equals to the power y dy. Okay, this is going good. This is going good till now. And then we have I dash of a is equals to 1 by a. This will be integral from 0 to infinity e to the power minus y of a, and then y of a minus 1, and then y to the power p minus 1 dy. Now we have I dash of a is equals to 1 by a. Now this is just gamma p by a minus 1 to the power p. Okay, now our goal is basically to find just I of 1. Yeah, our goal was to find I of 1, isn't it? Yeah, I of 1, then 1 will get equal to integral. So for that, we have to try to integrate this from 1 to infinity. Yeah, so that we get I of infinity minus I of 1. And I of infinity, we know that's just 0. Yeah, I of infinity is just 0. Yeah, isn't it 0? f infinity. So yeah, hmm, I guess no, I guess no. Okay, so if this is infinity, we will have Li of x1 back to infinity, so Lf0, yes, Lf0 is just there. Yeah, okay, fine. If infinity is 0, so if I integrate this over here, 1 to infinity, and this is I of infinity minus I of 1, yeah. I of infinity is just 0, so we are just left with I of 1, which is the required answer of ours, yeah. And now we need to do the other side. We integral from 1 to infinity, gamma p by a minus 1 to the power p, and then d. Okay, now good. Now this is just minus if1. Now for this one, if you let, let's say x is equals to a minus 1, this will clearly simplify. This will go from 0 to infinity, and then gamma p. Now a is just x plus 1, and x to the power p. Now dA is just dx. Yeah? And gamma p is just constant, so it can be taken out of the integral. Minus if1 is equals to gamma p integral from 0 to infinity x to the power minus p by 1 plus x dx. Yeah. After this, we have minus I of 1 as gamma p. Now this is just beta function of uh, okay. So this over here is just 1. Yeah. So this will be beta function of minus p. Yeah. And minus p, sorry, plus p minus 1. Because their sum needs to be eventual. Sorry, plus 2 plus 1. Yeah, no, I think I made a mistake. So this over here, it should be 1 greater than this. So minus p plus 1, and this should just be plus p. Yes, now it's good. Now this one should be 1 greater than this expression, and the sum should be 1. Yeah, now it's fine. Now we know that this is just uh, mm, yeah, 1 comma 1 minus p. I mean that is just Euler's reduction formula can be used over here. So we get gamma of p and then pi by sine pi p. Yeah. Now take minus to other side. So we get if1 is equals to minus gamma of p pi by sine pi p. And this is the answer. Yeah. So this is the answer. We have now finally got our solution, which is minus gamma of p pi by sine pi pi. This is clearly a beautiful answer, yeah. This is just minus gamma of p pi by sine of pi p. Yes, hope you enjoyed the video. Now, just to recap, we just created a condition where we could find the answer, but also we could use the Feynman's technique. After that, it's clearly simplified. We just used gamma function and got the answer. So, hope you enjoyed the video. Thanks for watching and look forward to seeing in the upcoming videos too.